You're watching this on a device powered by billions of tiny switches flipping on and off. Ones and zeros. The binary code. We are taught that the digital age began with modern electronics, vacuum tubes, silicon chips, and brilliant minds of the 20th century. But what if I told you the invisible foundation of your digital world wasn't born in a modern laboratory? What if the very first binary sequence was mathematically documented, over 2,000 years ago, hidden inside the rhythmic chants of ancient poetry? Pingala was not trying to build a computer. He was studying chandas, the rhythmic meter of Sanskrit poetry. A poem is built of syllables. Some are short, called Laghu, and some are long, called Guru. Pingala faced a combinatorial problem. If you have a specific number of syllables in a line, how many unique rhythmic patterns can you create without ever repeating yourself? To solve this, he needed a system. He assigned the short syllable, Laghu, one state, and the long syllable, Guru, another. What he was doing was mapping the physical sound of human speech into the world's very first functional bits. But how do you keep track of all these combinations? Pingala documented an algorithm called prastara. By following simple rules, he mapped poetic patterns to specific numerical sequences. And it gets crazier. To organize these sequences, he visualized them in a pyramid-like structure called the Tamatramru. Today, you might know it as Pascal's triangle, but Pingala mapped it out centuries before Pascal was even born. But what makes this truly revolutionary? Pingala used a concept essential to modern computing. Shunya, or zero. He used it as a vital placeholder. This concept is the exact logic behind modern bitwise operations in your computer. So how did this 2,000-year-old math reach your laptop? Through an incredible intellectual migration. From ancient Indian texts, this combinatorics logic traveled through the Islamic Golden Age. Scholars translated these algorithms, preserving them for centuries. Fast forward to the 17th century. European mathematician Gottfried Wilhelm Leibniz formally defined the modern binary number system. Did he invent it from scratch? No. He recognized the profound logic in ancient binary structures and the systemic counting methods born in antiquity. Look closely. A stanza of ancient Sanskrit verse mapping short and long syllables, structurally mirrors a modern data packet of ones and zeros. Why does this matter today? Because in 2026, whether you are running a classical supercomputer or building the world's most advanced quantum processors, Pingala's binary logic remains the absolute most efficient way to organize information in the universe. We often think of modern software as a purely mathematical invention. But reframed through history, software is the ultimate evolution of ancient linguistic science. The next time you write a line of code, remember, you aren't just programming a machine. You are continuing a 2,000-year-old tradition of finding rhythm in the chaos.